In Chapter 18, we're going to look at ethers, thiols, and sulfides. Ethers are compounds that have oxygen in them, and on either side of the oxygen you have a carbon attached. Just like alcohols have a carbon attached on one side and a hydrogen on the other side, the hydrogen is gone in the ether and you have a carbon chain. It can be any kind of carbon chain. It can be alkyl, aryl, meaning aromatic, or vinyl, meaning a double bond. And both of these two groups are bound to the same oxygen atom, so that oxygen has two carbons and two non-bonding pairs. We're also going to look at thiols, which look like alcohols, but in place of the oxygen you have a sulfur. And we're going to look at sulfides, which look like ethers, but have a sulfur in place of the oxygen. The examples of ethers are shown here. You can see this one's called diethyl ether. Notice there's a carbon chain on either side of the oxygen, and of course the oxygen has two non-bonding pairs. Anisole, this is a common name. Anisole has a phenyl group on one side and a methyl group on the other side. It's a common name for it is methylphenyl ether. And then this is called tetrahydrofuran. You've seen me refer to this before as THF, and it is just an ether also. Notice that the two ether chains attached to the oxygen are connected to each other around the backside. And there are more cyclic ethers like this, and cyclic ethers are extremely important when you start looking at sugars, because sugars exist in a type of cyclic ether. The simple ethers have common names that are derived by naming the alkyl group on either side and then ending with ether. So, for example, down here, we call this isopropyl methyl ether. Notice we put the alkyl groups that are attached to the oxygen in alphabetical order. So this over here is ethyl phenyl ether. All we're doing is we're just naming what is the carbon chain on one side, what is the carbon chain on the other side. But we only do this for the most simplest ethers. Notice that the oxygen has two non-bonding pairs and two carbon chains on it. Because the carbon chains tend to be very bulky, they squash the non-bonding pairs together, and so it widens the bond angle between the carbon, oxygen, and carbon. If it were purely tetrahedral with no regard to any kind of bulkiness of the alkyl group, you would have a bond angle of 109. But because these groups that are on the oxygen are rather bulky, they squish the non-bonding pairs together and they open up that angle. It is sp3 hybridized, and the oxygen, because it has non-bonding pairs on it, is very slightly polar. An ether will hydrogen bond to water, and you can get a small amount of water solubility if you don't have too many carbons. The ethyl phenyl ether would have very little water solubility, but the isopropyl methyl ether, because there's only 4 carbons, so go ahead and name these according to common nomenclature. The first one would be named, because you have propyl and methyl and M comes before P, you would name it methylpropyl ether. The second one is a butyl group in a methyl, so it's going to be butyl methyl ether. And this last one, it has both a propyl group and a butyl group, and B comes before P, so it's butyl propyl ether. When ethers are more complicated, what we do is we name the ether group as a substituent. And so these are then named as alkoxyalkanes. Let's look at this first one as an example. If we look, the principal chain, the longest chain, is actually going to be the cyclohexene group. So we're going to name this as a cyclohexene, and then this ether portion we're just going to name as a substituent. As a substituent, because it has 3 carbons, we name it prop, and then because it's an ether, we put oxy after it. It's on the number 3 carbon, so we actually call it propoxy cyclohexene. If it was a methyl group on the oxygen, then we would have called it 3-methoxy cyclohexene. Let's go down to the next one. We find the principal chain. Phenyl groups, aromatic, the phenyl group is not the principal chain because this is just an aromatic group. An alcohol group has functional group priority over that. This is just named as a substituent. So let's go ahead and look at this. The principal chain, the chain with the functional group on it, is a 3-pentanol. So that is my principal chain. This part right here, we're going to name as a substituent. This is phenyl, and then we're going to say oxy for it being attached to an oxygen as a substituent. So this is going to be called phenoxy. So what do we call this? We're going to number it on the number 2 carbon. So it's going to be 2-phenoxy and then 3-pentanol. Go ahead and try to name these compounds now. Okay, to name these compounds, the first one, you can see is symmetrical and a rather simple group attached. So common nomenclature would be easiest. So we look at that and we can say there are 2 cyclopentyl groups on it. So we can name it dicyclopentyl ether. If we decided we wanted to name this as an alkoxyalkane, what would we do? We would name the alkane part, which would be cyclopentane, and then we would say attached to that is a cyclopentoxy. So cyclopentoxy, cyclopentane. To name this group, I find the principal chain is going to be this cyclohexenol. So it's going to be a cyclohexenol. The number 1 carbon will be where the alcohol group is because it has priority over the ene. So this is 1, 2, 3. So it's going to be 3-cyclohexenol. 4, 5, 6 is where the ethoxy group is. So this is going to be 6-ethoxy, 3-cyclopentanol. Hexenol, I'm sorry. Thiols are named as alkane thiols. And so what we do is we find the chain, the carbon chain, name it as an alkane, and then just add thiol on the end. So right here, there's only 1 carbon, so we call this methane thiol. Cyclopentane thiol would be a cyclopentane with a thiol group on it. Sulfides are named just like the ethers, and we're just going to look at the common names. So the common names, you just name the 2 alkyl groups and then you end with sulfide, just like the alkyl-alkyl ethers. So dimethyl sulfide is just a sulfur with 2 methyl groups on it. Right down here, we have 2 different groups. So we've got an ethyl group and an isopropyl or a 2-propyl group. So we can call this ethyl 2-propyl sulfide, or you could say ethyl isopropyl sulfide.